All right, in this video we're going to look at function composition using charts and graphs. This should really be a quicker video here, so just stick with me as we go through this. So we see this chart and it's split up. We have a column of x, we have a column of f of x, we have a column of g of x. So really what this is telling us is when x is equal to -5, f of x equals 1. So f of -5 equals 1. When x is equal to -5, g of x equals -3. So g of -5 equals -3. So let's just try to follow along here. Let's do a couple of these functions. On the left, I have just like, oh, let's find f of 4. Then on the right is when we have the actual function composition problems. So f of 4, we are going to look. When the x value is 4, what is the f of x value? Well, when x is 4, f of x is equal to 8. So that tells me f of 4 is equal to 8. For this one, next one, g of -5. When x is equal to -5, my g of x is -3. So g of -5 is equal to -3. Then f of 10. When x is equal to 10, f of x is equal to 2. So f of 10 is equal to 2. Now over here is when we have the actual function composition. We have f of g of 3. Well, I'm going to start off by finding what is g of 3. Well, g of 3, let's see, when x is 3, g is 0. So f of g of 3 is the same thing as f of 0. So now I'm trying to say, well, when x is 0, what is f of x? Well, x is 0, f of x is 10. So f of g of 3 is the same thing as f of 0 because g of 3 is 0 and f of 0 is equal to 10. All right, for this next one, let's go g of f of -2. Well, f of -2 is 3. So this is the same thing as g of 3. And g of 3 we just saw was 0. All right, moving it right along. F of g of 4. So g of 4 is -2. So that's the same thing as f of -2. And f of -2 is equal to 3. That's the one we just saw there. All right, so that's function composition with a chart. Let's now check out function composition with a graph when we're given the graphs of f of x and g of x. So the important thing to remember with these graphs, guys, is any point on this graph. If I just pick a random point over here, this is some point x, comma, f of that x. So maybe it's, I don't know, in this case, -4. It's -4, comma, f of -4. Whatever the y value is, that's the function evaluated at the given x value. So like right here, if I see, all right, this is the point, and that's going to always happen. If this is the point 5, comma 8, right, if that's 5, comma 8, what that is telling me is that g of 5 is equal to 8. So this 8, when the function is evaluated at 5, so if I plug in 5, I'm getting out 8. All right, so that's what each of these points on the graph is telling me. So f of 0. F of 0, I can see that this point down here is 0, -4. So f of 0 must be -4. Then g of -2. G of -2, well, if I plug in -2, I'm getting out. That looks like -2, comma 1, so I would get out 1. F of 2. Well, f of 2, if I plug in 2, oops, I was accidentally looking at g of x. Let's look at f of x. F of 2, that appears to be a -8. All right, now f of g of 0. F of g of 0. So first I'll find g of 0. G of 0, so when x is 0, it looks like our y value is 3. So g of 0 is 3. So now I'm looking for what is f of 3. And f of 3, we can see with the point 3, -10. So f of 3 is -10. All right, g of f of negative 1. F of negative 1 is a negative 6, so now I'm looking at what's g of negative 6. G of negative 6 is negative 3. Beautiful. Now, f of g of negative 8, I missed a parentheses there, that's embarrassing. F of g of negative 8, g of negative 8 is negative 5, so then that's f of negative 5. Going over here, f of negative 5 is 6. All right, so f of negative 5 is 6. So this is how you evaluate functions at specific values, and also function composition when you're given the graphs and charts of the two functions.